right, so it says 7.2 day 2 says investigating inscribed and central angles. So kind of what Cam was just saying, these are our two big angles, but there's a lot of vocab that goes with them. We have an inscribed angle. Those are the angles that are on the circle. And then the central angle are the angles that are formed by the center of the circle. So I give you this here. What we're going to be looking for, you have this little table down here that we're going to fill out, at least a little bit. I don't know if we'll go all the way through this. But what I want you to do, if we kind of look through here, draw in a circle in the diagram. Actually, I'm going to use my fancy tool here. There we go. So draw that in. Do I try it, Mr. Krubowitz? Can I draw another one inside of it? And then what I'm going to have you do inside of it is inscribe a quadrilateral. So what that means is, let me actually not do that. Quadrilateral has four sides, right? And it's going to have four vertices, four little dots that create this. So put four dots anywhere you want it. I'm going to put one right there. Just put them on the circle someplace. So there's my first dot. I'm going to put my second dot up here. Doesn't matter where you put them. You just need four of them. I'll do my third one here, my fourth one down here. Then just connect them with their consecutive dots. So I'm going to take this one. I'm going to go to this one. That one's going to connect to its next one. Go to the next one. And then a next one. So whatever yours looks like, as long as you have a quadrilateral, so quad meaning four, this we dealt with in the past, so I have four sides. When it says inscribed, that means the four vertices are inscribed angles on that triangle, or on that circle. Okay? So that's our diagram. And then since we have B, C, D, and E, let's label these angles B, C, D, and E. Oh yeah, I did. And then I kind of like that actually. Okay. Now I don't know where my mouse is at either. There it is. So now, what I'm asked to do here with this little guy, you'll see a similar figure that is drawn into this. And we want to look for the relationships in the angle. So I am going to move this one to start. And when I move this one, this angle doesn't change. If it'll stop loading. There we go. This angle is going to stay 92, but the others are going to change. So notice how this is 92. This becomes 100. And if I move this, this remains 92, but the other two angles, so these opposite angles are going to change. So let me go to this, to where this becomes a 100-degree angle. So see this as a 100-degree angle. Notice how this one is also changing. So one more time, look at this angle and this angle. I can't see what they are. Those two change, right? And then the opposite angle of D doesn't. So let me go back to 90. So notice how this is 90, that's 90. Notice, so actually let's do that one first. Let's fill that in. So angle B and D are 88 and 92. So go to your table, put in letter B, it's an 88-degree angle. Go to letter D, just filling in your table. I'll do it in a minute, but just so you can see where I'm getting these from. Angle D is 92 degrees. This angle up here is C. That's a 90-degree angle. And then angle E is a 90-degree angle. Okay? What I want you to kind of notice now, if I did 90 and 90, notice how those are both 90-degree angles. What do those add up to be? 180. All right, maybe not as obvious. Maybe you hopefully don't need a calculator. What does 92 and 88 add up to be? Okay, 180, right? Look at the consecutive angles, though. 90 and 92, those would add up to be 182. These consecutive angles add up to be 178. All right, so let me adjust this. Let me go to where this was 80 and E on the bottom. So I want an 80-degree angle at the bottom. I can have the touch to do that. All right, so 80 degrees. So now fill in your table again. Keep B and D the same. So B is 88, D is 92. So that has not changed. Angle C is 100 now. So put that into that part of the table. And when angle C is 100, angle E is 80. And then last one with this angle moving, let me make this 120. There we go. So 88, 92, haven't changed those at all. But now angle C is 120. Angle, what is that? E is 60. All right. Are we noticing that these two angles, what is never changing about these two angles? They always equal 180, right? Now, we also said that these equal 180, 88 and 92 equals 180, but I haven't been changing them. So let me now move this guy. And if I move this one, now that's going to stay the same. Look at these guys. Do these two still add up to be 180 degrees? Yeah. Do the angles next to each other, we called them consecutive angles back in the day, are these consecutive angles adding up to be 180? No, it's a 196. Do these consecutive angles add up to be 196? No, it's a weird 184. So if we kind of look here, no matter where I move this, aren't the opposite angles, that's the one I wanted to keep actually. Don't your opposite angles always add up to be 180 degrees? Okay, so if we go back to your paper, you have your table hopefully filled out some of this. What we would see here, the consecutive angles, the angles that are next to each other, I ask if there's a relationship, whether you realize that's what I was asking or not. And what we would have said is no. If you look at the consecutive angles, they weren't adding up to be anything as a common relationship at all. So what I just mean again by that is 195 are consecutive. Those add up to be 195, but 110, 95, but 110 and 85 don't add up to be the same thing. So the consecutive angles do not follow a pattern. However, the opposite angles, this should say relationship. Does yours say relationship? And I just erase this. What did we say that relationship was? They always added up. Yeah. So we're going to put supplementary, right? That's the word that we used before. All right. They add up to equal 180 degrees. All right, so that, file away. If we have this sort of a shape, what that means is angle C and angle E, so angle C, we'll do plus, angle E must add up to be 180. Same with B and whatever this was, B and D. All right, add up to be 180. Oh, it turned my B into the arrow? Is that what happened? Is that where my B went? Okay. So opposite angles are supplementary. All right, next one. Real quick, cut to the chase a little more. All right, this one is using this. We're going to show a circle that is inscribed inside of a triangle. So now, drawing a triangle real quick. This is going to be a little harder. I'm not sure I can do this either. So there's that. Do your best to draw in a circle that is inscribed inside of this. So it would touch all three sides. Mine's going to look like an and it moved it. Darn it. I'm just going to show them on the computer because I am not an artist. So here's what this should look like. So if you can replicate this, draw this. So it's a circle basically inscribed, touching all three sides of a triangle. So look at that guy. If you can draw that, you're a better artist than I am. Hence the reason we have this thing up. Here's what I want you to notice about this now. What I'm going to do, I'm going to move C so that I create a nice horizontal line here. So flat line. Okay, so let's assume this is flat. It looks pretty flat to me. Look at where it intersects at F, right here. Notice how this is a vertical line. Do these look like they're forming a nice 90-degree angle? Right? The two that we know are always 90 degrees is a horizontal line and a vertical line. So if I make this horizontal, did this become a vertical line? Yeah. So This tangent line, remember a tangent line is only hitting the curve 1 point. So DC is tangent to the curve at F. That forms a 90-degree angle with that radius. Look at up here at letter E. Let me move this guy over so it becomes a vertical line. Best I can. So now, it's pretty good. Do we agree that that's at least really close to being a vertical line? Look at its radius that it is intersecting. Didn't that become a horizontal line? And we know vertical lines and horizontal lines are perpendicular to each other. So if these are perpendicular, aren't these 90-degree angles as well? And if we show the third and final one, and no matter how I move it, those angles don't change. So if I come over here, make this vertical, so there's my vertical line. Notice how this is now a horizontal line. That means this tangent line and this radius are perpendicular, forming 90-degree angles here. And no matter what I do, those angles never change. All right, if I move this around, you're always going to get a 90-degree angle. So what we want to get out of this, let me give you a better drawing. So let me make sure this is off. So draw in a circle. We won't inscribe the whole thing. Draw in a tangent line to that circle. So right here. What always happens 100% of the time is if I have a line that's tangent to the circle, so that's this red line right now. If I go to the center of the circle and draw a radius out to that exact same point, a tangent line and then the radius at that point will 100% of the time form 90-degree angles, always. If I draw a tangent line right here, draw a radius out to here, that's a 90-degree angle, that's a 90-degree angle. So a tangent line always forms 90-degree angles with the circle at that radius. All right. All right. Last one then, and at least we can get a problem or two done. So let me go to this guy. Come on, you. Oops. So here's what I want you to get out of this, and we'll draw the picture here in a minute so that when you see it in the future, you know what I'm talking about. What we want to focus on is, notice this central angle is 126. And then the tangent line to this, tangent line to that, and notice how we now form this angle right here. Let me give you a nice angle to work with. So let's make this 50 degrees. So if, come on. So if this is a 50-degree angle, notice how this is 130, the angle opposite of it. All right, do we agree that means they're supplementary? If I change that angle, so if I move it a little closer so the angle gets a little wider, so let's go 60, do these remain supplementary? Yes. If I pull it apart, let's move it to 45, did 45, and then the opposite angle, 135. Those also add up to be 135 degrees. So what we want to draw in and then show, don't worry about the table. There's a lot of work there that we don't have time for. Draw in a circle. And then put a dot at the top. Draw a tangent line there and extend it out far to the right. And then put a dot somewhere down here. And draw a tangent line to that circle. Don't ever hit that circle more than once. Notice how we create an angle right here. So let's call this angle number 1. Then go to your circle, put the center in. And then connect the center to those 2 points where the lines touch our circle. So there are now 2 things that we want to know about this. In the previous example, we know that this is a 90-degree angle up here. This is a 90-degree angle down here. So that we know from the previous example. So as we do some problems here in a minute and then on Monday and we follow up, we know those are 90 degrees. What I want you to do also, though, is label this as angle 2. And what we just found with the little diagram that I had on the computer didn't we say or see that these opposite angles always added up to be 180 degrees? So in this picture, when I have two tangent lines that intersect out here to form that angle, angle 1 and angle 2 add up to be 180 degrees all of the time. So those are the three new things. Kind of show it on the computer so you can see how it works. And then now, let's hammer some of these out real quick, see how many we can get done in 5 minutes. The first two, do those real quick. Numbers 1 and number 2. Get those done. These are old. We've been doing this now for the last couple of days. This is Cam's question, which one is which? One of these is going to be the exact same degree measure. The other one is going to be half of that measure. So see if we know which is which. All right, number 1, Ella. What'd you get, Ella?
75.
Good. That's a central angle. The central angle has the same degree measure as the arc that it intersects. Versus this guy has an inscribed angle. So this inscribed angle should be not the same. It should be 1/2 of the arc that it intersects. So if this was 64, this x should be 32. So this is the same. This is going to be 1/2. So that's what we've been working on for the last couple of days. Similar here, a little more complicated. We're going to put these two ideas together. So if I now want this to angle, we need to know what degree measure is the arc that it intersects. The previous problem, number 2, we just gave it to you. So while this is not marked, if we use the other angle idea, if we know the central angle is 68, doesn't that mean the arc must also be 68? So the inscribed angle that we are looking for should be half of this. So x would have to be 34 degrees. All right. So number 4, real quick, same idea. Write down what we think x would have to be. Okay, anybody think they got it? Ahmed, what do you think?
Actually, goes to 300.
Not quite. Ella.
144?
Yeah, I like the 44 part, but it should just be 144. All right, because this should be half of the arc. So this should be half of the arc. So 72 twice should be 144. Okay.
I think I said 144.
I think you said 244.
No, I said 144.
Yes, 144 is paper.
I believe that, Ahmed.
Whatever.
Did he say 2? Did you think he said
Yeah,
2?
I heard 244.
Okay, maybe I said 244.
Okay.
Hang on.
All right, one more with an equation, because what we've been avoiding, and this is the moment Cam's been waiting for here when he started talking about numbers and variables and such, is we haven't really had to set up equations with these. So this is now kind of what we're getting into a little bit here with these next handful of problems. But what we just need to understand is this is the central angle. And doesn't the central angle equal the degree measure of its arc? So those should be equal to each other. So the idea of saying they're equal to each other is where our equation comes from. The central angle of 3x minus 4 should equal the arc of 80.
We're doing the square angle. We're like 1/2 of 3x.
Yeah. So let's do that now, because you can solve this. I can trust we can all solve that. So now, just so we can see one of these, the inscribed angle should be half of this. So we have two options right now. We could take x plus 8, and we can't say it equals 110, right? What would it equal? 55, because it would be half of that. Or you could take 2 of these. I would need to take 2 of these guys. And if I double it, then it would equal the 110, effectively the same exact thing. And that's our equation. And then again, we've solved a ton of these equations recently. Then you don't have to worry about a frac. Yeah, it's really up to you, whichever one you see the best. Okay. All right. There's no homework on this. No little quiz or anything. Monday we'll probably hit on some of those things. We'll do some more of these problems. I'll probably see if we kind of know some of this stuff on Monday with a little quiz. But that's it. Okay. So have a good weekend. We'll see you guys Monday. Did somebody raise their? Somebody pop in there.